All right, so what we're going to be doing is starting to talk about how do we actually name these molecules and ionic compounds that we've been talking about. So just to refresh your memory, we have molecules which are covalent bonded compounds, and they are when two nonmetals come together and they share their electrons. Whereas ionic bonds are where you have a metal joining with a nonmetal, and one of those atoms will give an electron to the other, which will receive it, and they're attracted to each other by positive and negative charges. So what I had asked you to do was fold a large sheet of white paper, and it's going to be our flow chart of how to do nomenclature. So we'll start by titling that very large sheet with nomenclature as a title, and you have 5 columns that I asked you to do, and we're going to be working with this column, column number 4, which we were going to write down as having molecule. So just to refresh your memory again, that's when you have a covalent bond. And again, that's when you have a non-metal plus a non-metal. And I know you can probably fit this much better into your paper. So rather than writing in this small space, I'm going to actually go to the next slide. You'll continue writing the information in this area right here, but I'll do it just on a larger screen. So under molecule, we're going to use an example of how we name molecules. I'm going to start off with CO2. I think most people will recognize that as carbon dioxide. Okay, you've seen it in biology before. So how is it that we can actually name these things based on this chemical formula? So here are the steps. So first you read the chemical formula. From left to
Good afternoon, your attention please. Will Mr. Fee
right.
Please call extension 791. Thank you.
So we're reading it from starting at carbon and then moving on to oxygen. So name the first element. And the first element we have here is obviously carbon. So we say carbon. And then next what you do is look at the number of the second item, or the second element. So determine prefix. And this is on your table 4.3. And under 4.3 it says 2 should be called di. All right, so if you take a look at that, you'll see that. So that means we start our second name with di. The fourth thing is we're going to name second element and end it with ide. And with oxygen it's a little bit different, so we start saying oxide. Okay, so that's why you have dioxide. All right, so I'm going to have you stop so that you can get all these notes. And then we're going to do a couple of examples on this page. All right, so you're back again. So let's try another one. Carbon and an oxygen. So again, using our strategy, we read left to right. So that means it is called carbon. In this case, we have no number here. So we assume there's just one. And so when we look at our table in 4.3, we say carbon monoxide. Remember to end with that last part. Let's try one more. Let's try one that all of you are familiar with, and that is H2O. What is its real name? Well, we start with the first element. We know we have hydrogen, but this time we see that there's a 2 here. So we have to call it dihydrogen. And we have oxygen next, but there's only, there's no number here. So we say monoxide. So water is actually truly called dihydrogen monoxide. All right, let's try one more. Let us try, how about this one? I'm going to have you try this on your own. So let's see if you get the answer that I got, which is diphosphorus trisol, and then we have that I, trisulfide. Okay, so that's how you name covalent bonded molecules. Remember, you read from left to right. You look at the subscript, these small numbers, to determine what your prefix is, and you make certain that the second element always ends with "ide." So one other category that I want to include is under molecules are the alkanes. So if you can place that, I'll go back here, in this area just below where it says alkane, we'll write down alkanes. These are a unique type of molecule because they only contain hydrogen and carbon and nothing else. And these you're going to actually have to memorize, but there's a system to it. So the first one is CH4. It's called methane. And this is the gas that you find usually excreted from living materials, particularly cows who release a lot of methane in terms of flatulence. The next alkane is C2H6. This is called ethane. The next one, C3H8, is called propane. I think many of you who have gone camping before have heard of that before. The next one is butane. And then the next one, we're going to see if you guys can start finding the pattern. So first of all, notice that every one of these alkanes always ends with ANE. So if it ends with an ANE, you know it is an alkane. All right? That means it only contains carbon and hydrogen. The next thing that's kind of cool is actually that alkanes have a chemical formula that's relatively easy to remember. So if you have X being a variable number, so let's say carbon, the number of carbons, the hydrogen is always determined by X times 2 plus 2. So let's test that out over here, okay? So here we have 2 carbons, and to get to 6, we take 2 times 2 plus 2 equals 6. For propane, you have 3 carbons, so that would be your X value. To find your hydrogen, it would be then 3 times 2, which equals 6, plus 2, which equals 8. All right, same with butane. 4 times 2 plus 2 equals 10. So, based on that formula, what would you expect the hydrogen number to be for C5? And hopefully you said 12. Okay, this one now gets easier. It's called pentane. Now it follows the typical rules. The C6H14 is called hexane. Okay, so I feel like once you know these 4, then the rest of them are relatively easy. And the only way I remember it is MEP-B. I know it doesn't sound very exciting, but you just kind of have to memorize that. And that's the end of the lesson.